Alright, this is Old Electronics Fan, and today we're looking at signal tracers. It's been an interesting journey for me in terms of looking for a signal tracer that would do everything I wanted, and it's something that I realized. Let me back up. I think that my particular journey toward a working signal tracer might be helpful to others. It took me longer than maybe it should have, in part because I didn't have a high demand for signal tracing. It seems like a lot of the radios I worked on didn't really need to be I didn't need to use a signal tracer on them to get them working. But in the recent past, I've run into some where it was extremely helpful to have a signal tracer. In fact, let me show you, and I forgot to dig this one out. Oh, excuse me there. Okay. Digging out everything, getting myself ready for this, and then I forgot. Alright, so this is a Conar. I don't know how exactly you pronounce it. Conar, I guess. Signal tracer. A friend of mine was in the electronic repair business. He had this. He didn't want it. He gave it to me. It wasn't entirely working when I got it, so I fixed it. One of the things that wasn't working was the signal. The eye tube was damaged. But even without the eye tube, this is pretty handy, so I used it before I repaired that. But so here's what this has, and here's why I started looking for something else. This band A has part of the AM broadcast bands from 170 to around 500. The band B is pretty much the entire AM band. I think it is the entire AM band. So it was very helpful, very useful when dealing with AM radios. And the other thing about this that's really nice is that this is a high gain amplifier, and this allows you to go after some very weak signals and actually be able to hear them. It's got an attenuator, and a coarse attenuator, and a fine attenuator. And one of the reasons for having this, in addition to being able to accommodate different signal levels, is that when this is in RF mode, you can use the eye tube to gauge the signal quality. And in the manual they tell you to use, when you're using the eye, to not let it overlap, but let the two edges come together. And I forget exactly why they explained it was not a good idea to let it overlap, but in any case, it'd be a more precise measurement if you every time you were checking the signal in a particular part of the radio, you got it to the same spot every time. That's where getting the eye to close it, just touching the two edges, just touching each other. That would give you pretty much the same indicator of level if you do that. So you can go down through the chain, and I think it was a Stuart Warner circuit diagram. But in the information they had, there's a little chart, if you will, and they told you this tube had this much gain, this had this much gain, and so on down the line. And so you could also use something like that to give yourself an indication of whether each chain is actually amplifying as it should, or if you've got a weak chain. So so it's got that. It's pretty useful. And then you put an audio frequency, and this doesn't work, and the eye doesn't work any longer either. So then it just becomes a straight audio frequency signal tracer. So it's a nice little unit, but the big problem I had with this was the fact that it was restricted by the frequency that it could handle. This is actually basically a TRF radio, and it's got two different sets of coils that allows it to pick up two different broadcast ranges. And if you actually grab the probe I can pick up my local radio station just by doing that, because it's just a antenna, basically. So that, as handy as that was, I wanted to get something that didn't require you to tune it, even though that was helpful. Sometimes you could tell whether the radio was way out of alignment by using that. But if I was going to trace the signal, say, in a shortwave, that would be of no use because shortwave was outside the range of that. So then, the other question I was asking, it was, does it matter what type of diode you use? Now, I think it matters less when you're staying in the AM broadcast range. You can test it for yourself, but I think all these diodes I have here, all of these are silicon diodes. All of these would work probably in the AM band. Let me think. I think though that the germanium, there's one in here. The germanium diode, first of all, has a lower voltage drop across it, and the other thing is that when you're signal tracing, these seem to provide higher volume than these. So, here's the thing that I want you to be aware of. I've got a glass diode here, I've got a glass diode here. Both of these are germanium types. I have a glass diode here. It is not germanium. And I know that because when I go to measure it, or when I do measure it, I have 0.5, oh darn. Let's get the meter into the screen here. There we go. So, come on, let's go. Really nice. So I have 0.5. You can't really see it. That says 0.566. That's silicon, even though it is glass. There's another little glass one, and this is also not germanium, 582. And of course this is the traditional black diode that we're all familiar with. And this one's actually, not very representative. I think that, I haven't looked up this diode. Well, it's supposed to be similar to these guys, but you're familiar with those. I'm going to leave it at that. Now, this one is interesting. I believe this is germanium, but it comes up with 0.344. Now compare that to this one. That's 0.259. Now, I've tested both of these, and this behaves like a germanium diode in circuit when you're testing against, well, I have my signal generator, and I've tested these using that, and you can definitely, when you get up around, let me think, get up around 6 megs and these start to fade, get up around 9 and these don't work at all. So if you're dealing with shortwave and you're dealing with higher frequencies, germanium is what you want. And given that these seem to give you more volume, I think I would stick with these, period. But anyway, so there's that. So I went on quite a journey, kind of a leisurely journey. I didn't spend a lot of time over the years investigating hard or putting in a lot of energy and really exploring the signal tracer circuits available. But I did some, and I came up with some different circuits. Now, a number of these came from All American 5. In fact, this one did. This was the first one. I actually built that into here. It's a basic little, I had an RCA jack on it, got a cord, and I put a probe on it. took an old broken probe and made use of that. And as luck would have it, I stumbled on a radio, this one, that didn't like the circuit design. It acted like the impedance at this point was too low, because when you put the probes across, even the plate circuit, the radio would almost stop playing, and you may or may not be able to hear what you're trying to hear in the amplifier that I used with this. It just didn't work very well, let's put it that way. Now, I watched All American 5 build this on a breadboard, and it worked on the radio that he was using. It worked just great. So this radio is fussy, and I ran into that when I tried to use this to compare analog to digital scopes. This just flat out would not behave itself. I wound up getting another radio to do that test because this just wouldn't play nice. So there's something about this that doesn't like you making connections to the plate or grid of the tubes. It's just very fussy. But I'm using this because with the right equipment, this works just fine. But this does not. So, and if you look at this circuit and you compare it to this one, the immediate difference that you see is this diode is in series, and this one is across, between the shield or common and the signal. So I think that may be the big issue for that radio, that this diode across across the common and the tube plate, the plate of the tube or the grid of the tube, it didn't like that very much. So, and I've been a little bit frustrated for a long time why this didn't work. And so I wound up using my Colnar for the things I could, but I'm coming up to on a radio that I want to work on that that wouldn't work and this didn't work. And that's what finally pushed me to try to come up with something different. So, in the course of searching for circuit diagrams, I found this. And I built it on a breadboard, and it was very quiet. Now they're saying 3 volts. These transistors will take more than that, and maybe if I bumped the voltage up, it would have behaved better. But I decided I didn't want to be bothered. I just want to move on and find something else. So I found another All American 5. Whoops. All American 5 circuit, which is this one. If you get in the video is 15 years old, so the video quality is not great. But if you can watch it and you can get stuff out of it, I'm hoping that having a better quality video, well, actually, let me take that back. I'm not going to show you building this because I'm going to get into what I think is a simpler and easier thing to do. But I did build this. In fact, I have down here this. I bought a junk box full of electronic stuff, electronic parts and pieces. I bought it primarily for the record changer, which is actually the BSR that shows up in some of my videos. But along with it, I got this radio, a Japanese stereo radio for a console, and a Magnavox amp and a bunch of other things. This, I think, was part of a portable record player, a record changer. I've seen designs like this before. This radio has a radio phono switch built into it, and I used that in conjunction with this to turn this into a signal tracer. Now, I want to kind of explain what you're looking at here. Let's move in a little bit more, I guess. Yeah. All right. So, in fact, let me bring over the circuit diagram to give you a point of reference here. All right. So where we're looking at is here, where the volume control is, and where you're going to make the change is on the high side of the volume. So you look at this volume. This goes straight down to common, or B plus and B minus. I'm sorry. So this side of the volume control goes to B minus. This side, even though at first glance looks like it does, it has this 150 picofarad cap here. What that means is audio cannot go through it. RF can. So I believe this is here for filtering. In fact, there's one here and one here. It's kind of like a little pi circuit designed to filter out RF noise in your audio. So this is the point at which you would break the circuit. Now, this 47k ohm resistor is coupling the audio from the front end of the radio, and it also plays a part in the ABC line that you see here. If you look at this circuit, you'll see there is no resistor in this part of the circuit. Let's go back here. If you were to put a resistor in here, it would be right at this point, because this connection and this connection are the new connections that you have added for your signal tracer, audio frequency, RF. So I'm showing this here. This wire would actually be directly connected to here, and you either just desolder it from here or cut the wire or whatever. Now also, the other thing that he did was he put in a switch at this point which would allow him to switch between radio and signal tracer. Well, actually, he didn't put it here, he put it here, so that the line coming from the radio would go straight back in, or if it was a resistor, he would put the resistor on the switch and then he would hook it back into the circuit with his switch. So he made that 15 years ago, and at the time he just drilled holes through the top of the case of a vintage radio, and I cringed a little bit when I saw that. He did comment saying in more recent comments that if you were building it today, he wouldn't drill holes in the radio. He would just build a separate little box. And we'll be getting into that in a minute. So if you, however, want to, and I've tested this and it actually works pretty good. Let me zoom back out a little bit here, and I'll show you in the back here. So this thing is extremely cheap. The chassis, there's the ground for the power, the power switch, when you turn it on, the leg of the power switch, which is right on the back of here, goes straight to the chassis. So that means when you plug this into an outlet and you plug it in such that the leg that goes to the power switch is hot, 120 volts, that goes straight to the chassis. So I put a polarized cord on this just to make sure, polarized cord, to make sure that I never get 120 volts on my chassis. And even though I do have, and I'll show you in a minute, even though I do have things in here to protect whatever I'm hooking up to from high voltage, I still don't want high voltage on here if I can avoid it. And I use this radio because it's a piece of junk. It's very tired. The front end doesn't work properly, and I have not troubleshot that. I'm just not even going to bother, because this will never get used as a radio. One of the speakers, it was a dual speaker set, and this speaker is toast. I may someday pull it out there and see if there's some way I can save that, should I have a need for one. Right now I don't, so it's going to sit. So, but what I did down here was I put a terminal strip, and I mounted all the components on here, and then I ran the wires up here to these 1/4-inch jacks, which would then allow me to plug in this as I needed to. And I'm pretty happy with how it came out. It works. and I can see it having value. It actually seems to be a little bit more sensitive than this circuit that you see sitting up here. I'm not sure why, but in any case it does. So I'm not unhappy that I built this. The biggest problem with this is I had to repair the radio and get it working properly. Bad electrolytic, or dying electrolytic. Now replace some of the caps in the output section, coupling caps and such, because I didn't want them to fail and do bad things. So I spent more time repairing the radio than turning it into a signal tracer. But now that it's done, it should be reliable and I can use it as needed. So that's this circuit. So is there anything else I want to mention? Oh yes, I was talking about safety. If you're doing something like that, I would encourage, and this was what All American 5 did, putting a cap between your B minus and your COM connection. How he had it set up is one cord connected here, he had another cord connected here, or here, depending on which one he wanted. So the concern, as I said before, is you don't want high voltage going to the B minus of the device that you're doing you're tracing signal on. Now, having a capacitor there does keep most of the AC off from there. There is still a small voltage there, and it can give you a little bit of a bite if you get between it and a real ground. So that's the other reason why I wanted to put a polarized cord on that, because I really didn't want 120 volts on this point. Okay, so the other thing is when you are, if this radio, the radio that I converted, had a 500 picofarad capacitor already across the volume control, but some radios don't, so you want to put that in. 0.001 for the RF leg and 0.02 for the audio frequency leg. And if you're looking at your circuit diagram, you'll see this, the movable connection, the center connection on your volume control, goes up through a capacitor to the grid of the detector tube. And that feeds from there right into your, in my case, 50C5 output amplifier, power amplifier, whatever you want to call it. And then, of course, this part here, I've just drawn it in, showing that that's B minus. So if you want to convert a radio, a tube radio, into a signal tracer, this is the circuit that you would use. I would recommend a germanium if you can get it. Try it with a regular one if you're not going to be doing anything but AM. It should work. Make sure this diode that I just measured funky, and so it's possible this won't work. In fact, I think I had this on a breadboard and it didn't work, so just be aware. Test your diodes to make sure that what you're putting in there is going to work for you. Alright, so that's that. Like I said, I'm not unhappy that I spent the time doing that, because I've got something I can use now. So let's see, next. Oh, alright. Why do we need diodes? Well, let's see here. This is my very sketchy thing here. Imagine that you had an AC power supply that could put out a curve like this. There isn't one, but suppose that could happen. And what would happen, so this is your zero line, there's your plus, there's your minus. So what would happen if you put your meter across the output of the AC power supply that's producing this curve? Well, number one, you wouldn't get this curve, because if that's the curve that it was doing, you would have zero voltage. And well, actually maybe it would. Yeah, actually an oscilloscope could reveal that. But if you put your meter across your AC power supply, you would have 0 volts, because the minus would be canceling the positive at every point. Well, there's a reason I raise this, because that's essentially the kind of signal that you're going to get. If you go to the RF section of a radio and you start measuring the RF with a scope, you're going to see, here's your zero line, you're going to see the identical signal above and below the zero line. And what that means is that this is going to cancel out this, which means that you won't be able to get any audio from this as it stands. So, what to do? Well, if you put a diode in the circuit, you lop off the top half of this, and you're left with this, and now you have signal that you can use, you have audio signal that you can use in your radio. If this stayed the way it was, radios would not be, we wouldn't have them because they wouldn't work. So that's why there is a detector tube with a diode in it, because you have to get rid of half of the signal. And so if you put in a single diode, you get this kind of a thing where you lop off the top half of the curve, the sine wave, and then you're left with something that actually you can measure the voltage on. And or in the case of an audio signal, you actually have audio that you can hear. If you don't have the diode, then you have audio. You can't hear it, even though the audio is there. Audio is there. It's being canceled. So there's that. So next, I've modified this already, and I probably shouldn't have, but I did, because I thought I was done with this video, but as it turns out I wasn't. So before, when this was wired up this way, I could demonstrate on this radio why I didn't like that circuit. But now I have this wired up like this, kind of. So here we have, and I put, what did I put? Oh, did I write it down? I did. Did I do that? Yes, I did. Okay. Alright, well, he shows that, the way he shows this, and this, by the way, is in his vacuum tube shortwave radio book, which you can download for free. Make sure that you pay attention to the password that's on it. He's got it password protected for some reason. This is on page 133 of that book. And this is a circuit that he came up with, I don't know when, maybe after he did the other one. This is designed to plug into a little stereo transistor of some sort that shows a mini plug here, looks like, and it's got left and right here, which means it's stereo. But he's got that tied together at this point, so that the pin and that ring are, the tip and ring are both tied together. So I guess you could probably plug this into, depending on the plug, you might be able to plug this into something that's mono. On some things, I think, would it matter? Maybe not. As long as the contact doesn't go beyond this point and grab the shield, then this plug will work in a mono device, and I can't remember if it does or not. But anyway, I digress. So anyway, so he's got a 0.01 cap here for the audio frequencies. He's got a 1N34-A. I would suggest, if that's not germanium, I would suggest using that. So that's the RF, and then after that he's got a 0.001 capacitor, and then he doesn't have a capacitor in this part here. And I think one of the reasons why he eliminated that capacitor is that he strongly, very highly recommends that when you're signal tracing something, that the radio you're doing a signal tracing on be connected to an isolation transformer. It's safer, and he also says that the radio seems to behave better when it's on an isolation transformer than when it's not. So if you're working on tube stuff, isolation transformer is a must. Even some of the transistor stuff wasn't entirely safe, so just be aware. So he did not put a capacitor in here. I made some modifications to what I put into this, because for one thing, I have a little switch on the end, AF, and the other thing is, I I know it's probably not necessary, but I kind of wanted the capacitor in the ground, just in case. So the capacitors are there because you don't want DC voltage going into your signal tracer amplifier, and if the amplifier, for whatever reason, is sending DC out, you don't want that going into your radio. So the capacitors protect both devices when you're doing signal tracing. So I was wanting, because I already had this, and I thought found it was convenient just to have a little switch to flick it back and forth between audio frequency and RF. I thought, well, I'm going to come up with a circuit that will allow me to do what I have here. And I thought I had seen a circuit somewhere that would allow me to just short across this part when I didn't want it and then unshort it. But when I started trying to draw a circuit diagram, either because I was tired or there just isn't any way to do it, the outcome I didn't like. Okay, so if you short this section, the capacitor is there and the audio frequency travels there and you're fine. And then you unshort this, and now you get the signal traveling through here. Now it's possible that the RF wouldn't go through that, and because of what it is. But I didn't like it. I didn't test it. I probably should have. So what I did instead, because this will guarantee that this will work the way I want to. I have a little single pole double throw switch, so I can short this side of the circuit and open that side of the circuit. That's my RF. I can short this side of the circuit and open this side of the circuit, and that's my audio frequency. That guarantees there's no crosstalk, there's no nothing as far as that goes. Now, I believe I've encountered, and I guess it kind of makes sense, if you forget to switch from RF to AF, and you connect to an AF circuit, you do hear some audio coming through here. And it's not as clean because the diode's trying to strip off half of it, but it's there. I was a little bit surprised by that, but I guess it kind of makes sense. And this 001 capacitor isn't small enough to keep audio from getting through. So anyway, so having this, so even with this, if you forget to switch between RF and AF, you can still get audio on this leg of the circuit. But I like this because I know it's going to work. I've already tested this, and this does work, and I'll show you that in a minute. And then, like I said, I put this here just as a final fail-safe against stupidity. I don't want high voltage DC on here, just in case I make a mistake. I just don't want it there. So it shouldn't be an issue, but like I said, well, with that radio, there is a chance that the chassis would be full 120 volts, unless you're using an isolation transformer, and then it becomes a non-issue. But this makes sure that no matter what I do, that's safe. So let's. So this is actually the culmination of my search for a better circuit for this, because I kept thinking, I'm pretty sure my problem with this radio is that the impedance is too low. And I kept thinking, well, what if I put this diode in series? But I never did it. And then when I finally decided I was going to find a better circuit diagram, I decided to. Well, I explained what I did. So, and I'm pretty convinced that this circuit is not ideal. As I found out, some radios don't like this. Um, so now what I want to do is I'm going to turn this on. I'm going to, let's see. I was going to use this, but I don't need to because this and this are identical now. I built this when this was not the same as this, or yeah. I was using this earlier, oh no, back up. I was using this earlier because this and this were not the same, but now they are. So I don't know why I set that up. I was not thinking. So, here's what I'm going to do. And this is kind of why I like it. How did I misplace that? Yes. Alright, well I'm going to cheat. I'm going to grab this. Maybe that will reach? Or not? Now let's see. Does that screw me up? I want to go in here. I guess that'll work. Alright. Okay, so what I've done is I have an aux port that goes into this little amplifier down here. Convenient having that set up like that. So now I got to get this hooked into my B- on this radio. Right there. And I think I may want to. Well, one of the things you'll run into, especially with audio stuff, if your cables are too long, you can wind up with humming. But I may need to have this one a little bit longer than it is because on some radios this might be a problem. So I may have to fix that. But anyway, alright, so, am I ready? I hope so. Let's see here. Well, let's fire that up because it takes a minute. And turn that on. That might tell me that it's working, or when it's working. And while I'm waiting for that, I'm going to show you. What do I do with that? Is that here? I must have moved that. It's not. Oh, here we are. Okay. This little circuit diagram I dug up because when I was working on that tube radio that I just showed you, there was no identification on it whatsoever. No brand, no chassis number, no nothing. There is absolutely nothing on that. They don't even have so much as a stamp on the metal of that chassis anywhere. I have no idea what it is or what it was in. Nothing. So, that's just a basic All-American 5. There's different, where am I heading? Okay. This is from a downloaded RCA tube manual. I know that the RCA tube manuals have schematics in the back. I have a hard copy of a version or a volume 22. This is 25. I like this one better because all the values are already on the circuit diagram. Now, even though there's similarities between this and that radio, there are lots of differences. Number one, that has a phono connection. And number two, they designed that differently than this. You'll notice on this one, they have a capacitor between chassis ground and B-. On that radio, there's nothing. It's just B- goes straight to chassis. And so when the power switch is turned on, where's this power switch? Right here. Okay, there should be, alright, yes. So, when the power switch is turned on and this leg of your power cord is hot, 120 volts goes over here and goes straight to the B minus side of things. And if B minus is directly to the chassis, the new chassis is fully hot. Not entirely safe. So, but anyway, I found this useful. Number one, it gave me 2 pinouts, which was handy. It gave me the basic idea of how the radio was set up. On the radio I'm working on, it's got 3 capacitors. This one had 2. One here, I think this is bypass, and this is just your filtering capacitor. On the old radio that I just showed you, they actually had a pi circuit here, a capacitor, then a resistor, then another 50 microfarad capacitor. Anyway, there were differences. So, helpful as this may be, just know that this is could be a useful guideline for a no-namey radio. Just don't expect it to be identical or even close. I've run into that problem even within different versions of the schematic for a particular radio, and the schematics were made for that radio, but they made some fairly substantial changes sometimes between versions. So anyway, I digress. So I'm going to take this, I'm going to leave this here. This is a better printout, cleaner, sharper printout than the schematic for that radio. I'm going to put that here, so I have it to refer to, and we don't need that, so we're going to put this here. We're going to put that there for now. And, I guess, yeah, we'll do that there for now. I'll bring it around when I, can I maybe move these together, maybe? Watch your fingers. And then I can do this, maybe. Yeah, there we are. Alright. So, this radio is on, but this is not tuned properly. Let's see here. Where are you? There it is. Okay, so I'm keeping that volume fairly low because I don't want, when I get into doing signal tracing, things can get sometimes loud. Okay, alright, so I need to be ready to turn that volume down. Okay, so what I'm going to do is I'm going to start right at the beginning of the chain, which is here. And now, this is where your antenna comes in. And on the original signal tracer circuit that All American 5 used, and the radio he was using for signal tracer, he was actually able to pick up signal here, which I was a little bit surprised by that. This will not. The Connor will also pick up signal here, but basically that probe is in it. Basically, by hooking that probe to this, you're just giving it an antenna so it can get a radio station. So, anyway, so pin 1, yeah. So we're going to go to pin 5 on this 12BE6, and let's see what we get. So 12, pin 5, let's go over here. Let's see, I think, here we are, 1, 2, 3, 4, 5. Ooh. Why are you humming? Oh, because I'm on AF. That helps. There we are. Okay. So, what you just heard was me forgetting to switch my switch to radio frequency instead of RF. So on pin 5, you can hear a little bit of signal. This is the first chain of amplification. But I want to show you something. Let's swing this out a little bit. So pin 5 is right here. and it goes down through here, and this is one leg of the transformer, IF transformer here. So if I go here, I have this, and I do, so then I go over here, it's a lot quieter. So the resistance of the, let me quiet this down, so it's easier to hear. So the volume between here and here gets less because of the effect of the IF can. So I went from here to here, which is pin 1 of this 12BA6. So let's now go to the pin 5 of the 12BA6. So 1, 2, 3, 4, 5. As you can, stop it. It doesn't like connections. So there's this, and this is the first leg of the IF can. Now watch this. Turning this to the same volume on the amp results in a lower volume. So, at least on this radio, and I'm betting on others, each time you go through an IF can, you lose a little bit of gain. So this then is, if we are here, let's see, 1, 2, 3, yes. So let's look at this here. So this leg of the transformer goes down here and goes to the diode. Now, you should be able to get a bit of audio as well as RF at this point. This setup doesn't seem, on this radio at least, doesn't seem to give me that. I'm not even going to bother going there because you don't really need to know that. All you need to know is that you've got RF here. And the other thing, if you're tracing because you don't have signal, then your next step is, if you have signal here, your next step is to go to the plate. Now it's curious, let me go to, can I go to, let's see, can I don't know which one is which. Because you could go to this leg of the volume control, and I didn't trace that out, so I don't know where that is. So that's one, that's the other leg, that's this leg of or the bottom pin, bottom connection to the IF can. Let's go back here. I'm not going to trace it out. I think that might be, so this might be the volume control here, but we're not going to worry about that because we're going to go to pin 7. Now this is where it's a whole lot louder. It should anyway. Pin, I said 7, right? Yes. So there's 5, 6, 7. Oh, okay, now. Alright, I left this in RF. And here's all distorted. Now I switch it to AF. So there you are. So I have just demonstrated what happens when you forget to switch between RF and AF. So you heard on RF you heard audio coming through, but very distorted because well, you've got a capacitor that's not really made for that audio, and you have a diode that's stripping half the signal off, and so all is not well there. So we've gone here. All of our IF cans are behind us, so the next step is going to be here on pin 5 of our 50C5. So pin 5, our C5 is 1, 2, 3, 4, 5. So there's that, and then if I go to pin 7, I barely have to use my volume control, I have lots of it. So that's how that works, and this circuit is the one I just showed you, and it works very well. So if you want a simple signal tracer that you can just plug into a little amp like I have, it works, it does the job. and I demonstrated what happens when you forget to switch between these two. It's not fatal if you do, it's just you don't get the sound that you're hoping for. Um, I'll pause that. So that's kind of the final step in my journey toward a handy, versatile signal tracer. Now I am going to be working on a shortwave radio. I actually have restored it, but somewhere along the line the shortwave stopped working. I don't know if it's because of a mistake I made or a tube issue or whatever. It could be either one of those. The Philco radio, the 38-7, I was all set to put that back in the case and call it done. Actually, I think I did have it in the case. I was all ready to bolt everything in, and I think it was the detector tube that went bye-bye. Just, it was playing 1 minute and not the next. So things happened. So that's, at some point I'm hoping to get to that. I've got actually another project I'm trying to finish up that has to happen, well, in my mind has to happen before I get to that. So, I hope this is helpful to somebody. I kind of wished I had found something like this sooner, but hey, I found it, it works, it does, even this fussy little radio now tolerates me using that signal tracer on it, whereas the other one did not, as I mentioned. So, yeah, I guess I'm going to wrap up here. I'm just trying to think about anything else that I might have forgotten. And I can't think of anything. So, anyway, so if you like this, if it was helpful, leave a comment, leave a like. If you like the channel, subscribe, please. I would appreciate that. I appreciate anyone who watches my videos all the way to the end. I'm grateful for that. And hopefully I'll have you with me on my next video, whatever that might be.